My name is Jim Fujimoto, and I'm on the faculty of the Department of Electrical Engineering and Computer Science and the Research Laboratory of Electronics here at MIT. My group is involved in optics research and in particular biophotonics, development of optical imaging technologies, as well as in development of femtosecond optics and applications to ultrafast phenomena. As an engineer and also as a scientist, I'm very motivated by looking at complex problems and trying to solve them, both from a technical viewpoint as well as from an administrative viewpoint. And the knowledge that the solution to these problems can really have an impact or contribute to society to improve healthcare, I think is one of the most important things to me. One of the things that you will see in our labs is examples of technology that we're developing that will be used in the clinical environment. One of the interesting points about this research is that it requires a broad skill set. So in biophotonics, of course, we need to understand optics, we need to understand basic physics very well, but we also need to understand concepts in clinical medicine. One of the major areas of emphasis of our group is optical coherence tomography, or OCT. This is an example of medical imaging technology, and it shows the concept of vertical integration, starting from fundamental scientific advances, performing engineering to develop systems technology, and then applying this technology in the clinic to make real contributions to clinical medicine. In the area of biomedicine, collaboration plays an extremely important role because in our case we're interested in developing technology for clinical applications. And that requires a very close interaction with clinicians who are specialists in their field. One of the great things about being at MIT and RLE is that we have students who are really among the top students in the country. And because of this, we have a very dynamic environment for fundamental research as well as innovation. One of the advantages of working at MIT and in the Boston environment in general is that we have this great infrastructure with the medical schools. And just the environment and the ability to interact directly with collaborators who are in clinical medicine as well as in fundamental biological research, which we have at MIT and at Harvard. That's, I think, a unique opportunity and infrastructure to develop this type of research. I'm passionate about my work because it's an opportunity to apply engineering concepts to problems that really have significance to society. I feel very fortunate to have the opportunity to work here at MIT because we've really had the opportunity to work with some of the best collaborators, from engineering to entrepreneurship and clinical medicine. I think without this, it really would be impossible to make scientific or engineering advances.